Okay, so let me get a drawing thing and let's take this bigger here. Okay, we'll go ahead and get started. All right, so the notes for today, they're on the Otis lesson for today, and we're going to start, actually, we're going to look at the bottom first. Okay, so in the textbook, in the appendix, so I'm starting on page A19, is a very long table of these values. It has other things in it too, but this is just a sampling to be able to use for the problems that are on this sheet. But you may need, I think in the quest, I tried to pick ones where they're giving you the delta H values. But if there's some that they don't, you have that table at the end of the textbook. So let's just look at what these are. Okay, so these are where it has delta HF. So that is an enthalpy of formation. All right, and so what that means is the enthalpy, that is the enthalpy change that occurs when that compound is formed from its elements when the elements are in their standard state. All right, and we talked about it before, and I think it's got it up in the notes, but standard state, the pressure is 1 atmosphere, but the temperature is 25 degrees Celsius. So it's like normal room temperature. And essentially, what we talked before about how with enthalpy, we're always looking at the change in enthalpy, just because it would be really complex to try to measure all the different forms of energy that are going on within a molecule. And in order to look at a change, you kind of have to define something as zero. And so that's what they define the enthalpy of an element in its standard state, that is defined as zero, that delta H is zero. So you'll see, I think it does have it in the table in your book, but that's something to remember, that, let me go down below here, that the delta H of formation for an element in its standard state is zero. Okay, so they define that as zero. So what you'll see is, like, say, for example, iron as a solid, or oxygen as a gas. So their delta HF is going to be zero, which is good to remember, because in some problems that involve elements where you're trying to find its enthalpy, they'll leave that out. Like, it'll be assumed that you know that has a value of zero. So what these are then, right, in this table. So for example, let's take the CH4 that we have, that very first one there. So that is carbon plus hydrogen. So carbon solid, hydrogen gas yields CH4, and the equation is balanced so that there is a 1 on the compound. So this would be, say, a 1 carbon, 2 hydrogens is 1 CH4. So that equation is what, when I give a delta H of formation, it's that equation is minus 74.8. So these values in this table, they represent the reaction of the elements in their standard state combining to form that particular compound on there. Okay. All right. And so essentially what we're doing with these, it's kind of kind of like Hess's law, but because we're using these delta HFs and sort of combining them, um, but we have a different equation that we use them in, that makes it a little easier. So we'll go back up, and so this right here, this is the equation, all right, and we're going to have other thermochemistry related values that use this same format. So our delta H of a reaction is equal to the sum of the delta H of the products minus the sum of the delta H's of formation of the reactants. All right, and if there is and usually in this equation, this generic one, it'll have like a value in here, like just a variable. I think a lot of times it's M, which essentially means that, I'm putting it in the wrong place, it's going to go there. Essentially means that if there is a coefficient on that particular product or reactant, you're going to multiply the delta H of formation by that coefficient. Okay, and because this equation is, we'll use it a lot, all right, with delta H's, and in the future we'll see delta S and delta G. But this is what we refer to as the Big Mama equation. Okay, so when we talk about Big Mama, we just mean the sum of the product values minus the sum of the reactant values. Okay, that's Big Mama. All right, so let's take a look, all right, at how we would apply this. Okay, so, and let's do one that actually has reactants on it. So let's look at B. Okay, so products minus reactants. So the delta H for this reaction, I'm going to just write it, is going to be 2 times the delta H of formation of CO2 minus 2 times the delta H of formation of carbon monoxide plus the delta H of formation of oxygen. Okay, so we would go and look up those values. All right, so CO2 is negative 393.5. So I'm going to have 2 times negative 393.5 minus 2 times, and I have carbon monoxide. Well, I thought I had all of them in there. All right, hang on just a minute. Let me grab a textbook. Let's see. Okay, so again, back starts on A19, and they're sorted in alphabetical by the primary element. So carbon monoxide is going to be minus 110.5. Okay, so 2 times negative 110.5, and then plus the delta HF of oxygen gas is going to be 0 in there. All right, so we have 2 times negative 393.5, so that gives me minus 787 minus 2 times 110. Minus a minus 221. So that's going to equal plus, so negative 5 66. So this would be the value, like, so if I wrote it up here, so delta H for that reaction then is negative 566 on there. All right, let's do
How are they getting the numbers for that text? How are they getting the textbook numbers?
the
change in enthalpy for just the single molecules.
oh, these would have been um, experimentally determined at some point.
Okay.
Yeah. Okay. Or the other way, which we'll do it next semester, is you can, like, they have values for the energy of the bonds, and so they can look at in a reaction occurring what bonds are being broken, what bonds are formed, and they can look at like the overall energy change that happens that way as well. So that's another way that you could get these values
Okay,
in there.
thank you.
Mhm. All right, let's look at D. All right, and so let me go down and get the numbers first. So we have H2S, so minus 20.1. That one's going to be 0. And liquid water is minus 285.8. Minus 285.8. And then 2SO2. SO2 is minus 296.1. All right, minus 296.1. Okay, so products minus reactants. So this is going to be, so I have 2 times negative 285.8 plus 2 times negative 296.1, and then minus 2 times minus 20.1, and then plus 0 for the oxygen there. So I have 2 times negative 2.8 plus 2 times negative 2.1. So I get a minus 1163.8. That's minus a minus. That's going to be plus 2 times. Okay, so that plus 1163.8. So minus 1123.6. Okay, so again, that would be, we were doing this reaction, delta H is negative 1123.6. Okay. So that's kind of straightforward. The only variation you might get is sometimes they'll give you the delta H for the reaction, and then they'll leave off one of the individual delta H's. So, and ask you to solve for that, which we may see. I can't remember. You might see something like that in the quest, but that's kind of the only real variation that you have on this kind of a problem here. So any questions? Do we need to do another one on that?
I understand. I think we're good.
Okay, yeah, just remember products minus reactants. Okay, so let's break from that and let's go, because I think I saw some stuff on the Jamboard today. Let me find it. There it is over there. Okay. I think I answered. There was one there. I did omit one, which is actually, as of today, you could technically do that, but somehow I had one slip in that was that you needed to use delta H formation on. So, okay, so here, oh goodness, let me pull up the quest so I can see the reactions written out. Let's see, because that's number 3, it says. Uh, and that's a Hess's law. Okay. Mm. Oh, it's being very slow. All right, let me try. Okay, so the reaction we're trying to find is 2N2 plus 5O2 yields 2N2O5. Hang on. Okay, so we're given H2 plus 1/2 O2 is the delta H for that. Oops, wait, gotta finish it. Is H2O, and then, so our delta H minus 289, and then we have N2O5 plus 8, oh, okay, that's a liquid, yeah, they're both liquid, okay. H2O, it's 2HNO3, that's minus 79.5. And then 1/2, I don't know why I didn't leave more room. Oh well, 1/2 N2 plus 3/2 O2 is, whoops, nope, I'm done with that. Plus 1/2 H2 yields HNO3, and that's negative 173.2. Okay, so let me just make some suggestions here rather than working it completely out, because I want you guys to have practice doing this. So this one, I would say you're going to flip and then multiply by 2 on that equation to get the 2N2O5 on the product side. And then this one here, you'll multiply through by 4 to get your 2N2.
You turn the printer on?
And then let's see, we're flipping that. That one is flipped. All right. And so we're going to have a 2H2O on the product side from this flipping the second one and times 2. So, and we want the water to cancel. So you're going to have to flip this one and then multiply by 2 to do that. And once you've done that, right, your hydrogens are going to cancel, the waters will cancel, and then all of those oxygens should add up to 5 oxygens on that. So I think that's what you need to do to those. And so that's going to so we'll change the sign and times 2 for the first delta H, change the sign times 2 for the second, and the third will just multiply by 4. So that should work for that one. All right, so let's see this other number 6. Okay, so for number 6, we have 2 HCl plus F2 yields 2 HF plus Cl2. Okay, in our equations, we have 4 HCl plus O2 yields 2 H2O plus 2
Did it print?
2 delta A minus 2O2.4, and then 1/2 H2 plus 1/2 F2 yields HF, and then H2 plus 1/2 O2 yields H2O. They're both liquids. That one's a minus 600, minus 285.8. Okay. All right, so this one is, all right, so the HCl is on the right, the correct side. So this one I'm going to multiply by 1/2 to get the 2 HCl. The fluorine is on the correct side here. So I'm going to multiply by 2. So that'll give me a 1 on the fluorine, and that'll give me a 2 on the HF. So that'll get those two. Oh, and that first one, the Cl2, we'll get that one as well. All right, and then we're going to want to get rid of the water, for example. So it's going to have a 1, and it'll be on the product side. So I think if you just flip this one, that should get everything to cancel, because that'll cancel your oxygens as well. And that'll cancel the hydrogens as well. So I think that's what I would recommend on that one. On there, that should make it work. All right, is there any other? Oop, while I'm thinking about it, let me start another Jamboard, because this one is full. All right, let's do okay, so it's going to be Unit 5, Part 3. Okay, and let me share that with you guys. Okay, so we got a new Jamboard now as well. Okay, so it's wanting, again, let me pull it up here. Number 7. Okay, so it's given us CH4 plus 2O2 yields CO2 plus 2H2O, and CH4 plus CO2 gives me 2CO plus 2H2, and go back up. CH4 plus H2O yields CO plus 3H2. All right, and it wants us to find CH4 plus 3 halves O2 to CO plus 2H2O. Okay, so, all right, what are we doing here? We've got 1 CH4 and okay, O2 is only in the first one. So I would start, so we want it to be 3 halves. So I'm going to, whoops. Let's see, that one. Let's see. So 3, is that right? 3/4? So if I multiply by 3/4, that's going to give me, yeah, that'd be right. That would be 3 halves. Okay. All right, so that's going to get the O2 where it should be. And all right, what's next? I got CO in. Is that going to fix the, okay, that won't fix the water though. Okay, so I'm going to get, let's see. So when I multiply through there, I'm going to end up with 3 halves H2O up here. All right, and I need 2. Okay, so I need another 1/2 H2O on the product side. So this one, I'm going to flip and I'm going to multiply by 1/2. All right, and that'll fix my waters. When I add those two together, that'll give me my 2 waters. So I've got that one, I've got that one. All right, and so what's that going to do? That's going to put CO over on this side, and it'll be, I'll have a 1/2 CO on that side. And I need a 1. Okay, so I want to, so half is going to get canceled. So this needs to be 1.5 as well. So I think I'm going to, if I do a times 3/4 again on that one, so that'll make that 1.5, and then half will get canceled, which will make it 1. Okay, I'll let you guys work that one out and just check it with those suggestions and see. Yeah, it gets kind of tricky when you get all those fractions in there. But I think I've thought it through right. But you guys can double check me on that to see if that'll get you the right thing on there. Okay, let's see. Were there any other questions or anything? Because I know we ran out of pages on the Jamboard, so we're on a new Jamboard now. If anybody has any other questions about that. Okay, well, I will see you guys tomorrow then.
Bye.
All right, bye-bye.
Hi, Miss Billy. Miss Billy.
Yeah.
I'm sorry. I just wanted to let you know. I probably should have emailed you this. I wasn't at yesterday's class because I was taking the English final for Miss Lepore. It was
Oh.
on-demand assessment. Like you had to write it within the 2-hour time span, so I just couldn't hop on. But
Yeah.
I probably should let you know that by email.
Oh, no, not a problem.
All right.
It's all good. All right.
Bye.
See you guys tomorrow.